Hello, dear student. Now you see the monostable multivibrator using IC555. Its another name is a one-shot multivibrator because in this multivibrator, one state of the multivibrator output is stable. So off state is stable and another is a stable state. Means if output is low, to make output high, you have to apply the triggering. Once the triggering is applied and it suddenly becomes low and again high, so at that instant, what will happen? The output will change from low to high. But for this time period, output remain high only for this. Then automatically the state is changed T on to T off. Means that to make the state change from off to on, we require triggering. But this circuit will change the state from on to off automatically. Means that we require triggering only to change the state from T off to T on. Circuit automatically gets changed from T on to T off. That's why it is called as a monostable multivibrator. This is a triggering applied to pin number 2. This is a voltage waveform across capacitor and this is the output. This is output. Now here in this circuit, this is RA resistor. This is capacitor, pin number 7 discharge pin, and this is 6. So 7 and 6 are short. And this is pin number 2 where we are applying the high voltage initially. Okay. This is capacitor, sorry, VC pin. This is external one capacitor to remove the ripple from the VCC. And this is ground. Now, here initially the triggering is high. So triggering is high here. So triggering is high. As the triggering is high means this voltage is high. Triggering is it is a lower comparator. This is VCC by 3 voltage which is a fixed voltage, and this triggering is as the triggering is high means that minus Vsat output will be minus Vsat, which is applied to the R input of the SR flip flop. Okay, as R is 100% means that flip flop is will be set state. It is in set state means Q is equal to 1 and Q bar is 0. So output is we are getting at the Q bar means pin number 3. So output is low. And capacitor is completely discharged through that transistor because output Q of the SR flip-flop is high and the base of the transistor is connected to Q. So transistor is on, and as transistor is on means that this capacitor is completely discharged through that transistor. So obviously voltage across the capacitor is almost 0. So voltage across capacitor is almost 0. Output voltage is 0. This is a Q bar actually here. Now as soon as the triggering becomes low means this voltage becomes suddenly low and this voltage is high. So output of this lower comparator which is inside the IC that becomes plus Vsat, and as the lower comparator output becomes plus Vsat which is applied to the R input of the SR flip-flop. So obviously flip-flop is reset. Flip-flop reset means Q is equal to 0 and Q bar is equal to 1 means high. So Q bar is the output. So what will happen? The output suddenly becomes high. Now as the transistor is off, so this capacitor will charge. So here something is wrong. So capacitor is charged. So capacitor will charge through this RA and this capacitor. So from VCC, RA and this capacitor. So it will charge. So it is charged exponentially. Now it will try to charge towards the actually VCC. Suppose for example 9 volt. But as soon as the voltage across capacitor becomes equal to twice VCC by 3, and this voltage is applied to the 6 pin number 6, that is a threshold voltage of upper comparator. So as soon as the voltage becomes equal to twice VCC by 3, so output of the upper comparator becomes equal to plus Vsat, so which is applied to the yes input of the SR flip flop. And as it becomes 1, means yes become 1, so flip flop is set. As the flip flop is set, means Q is equal to 1 and Q bar, which is output, is 0. So at this instant T2 output suddenly becomes 0. And as the transistor is on, this capacitor is suddenly discharged through the transistor. So this capacitor, pin number 7, where collector of the transistor is connected, so it is suddenly discharged. Again, this state remain as it is unless and until you don't decrease this triggering input. So because triggering input is hold high, again at this point if the triggering becomes low, again state will be changed, T off to T on, capacitor will charge. When this capacitor is charged to twice VCC by 3, again the flip flop become a reset, so output suddenly becomes on. Flip flop is set at this point because yes becomes equal to 1. Lower upper comparator output becomes plus Vset. So again transistor becomes on and then capacitor will be discharged. So in this way, this circuit gives the waveform like this. This state is stable state. This is quasi-stable, means it is stable for only few seconds depending upon the charging rate of the capacitor. When this voltage across the capacitor becomes equal to the twice VCC by 3, so obviously the upper comparator output becomes plus Vsat, flip flop becomes set. So Q becomes 1, Q bar becomes 0 over here. So this is a one-shot multivibrator. So this time period T on, means charging period Tc is equal to 1.1 Ra into C in second. So this is, we can say, a stable, sorry, monostable multivibrator. Thank you.